Probability 2 Bernoulli Trials Homework, page 93. So there was one or two questions on question 14 and 15 on page 93. So we're just going to go through these questions here. So the first one was 14, where it says, whenever Jimmy fires an arrow, he has a quarter chance of hitting a target. So what we would say here is that the success is that he hits the target. And we're told he fires the arrow 10 times. Sorry, he fires 10 arrows. So therefore our number of trials is going to be 10. Our probability of success is that he hits the target, and we're told that's 1 in 4. So that's hitting the target. Q then obviously is the probability of failure, which would be 1 minus a quarter, in other words 3/4. In other words, doesn't hit the target. And then our number of successes will depend on which part of the question we're looking at. So if we look at the first part of the question, it says he hits the target the first 3 times but misses the rest. So we could do this as a traditional probability in that he has hits the target the first 3 times and then misses the rest. So basically if he hits the target, that means he has success, so he hits it. Then he hits it, then he hits it, and then he misses the rest would be 3/4, 3/4, 3/4, 3/4, 3/4, 1, 2, 3, 4, 5, 3/4. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3/4, which of course could be simplified down to he hits it the first 3 times, so that's a quarter 3 times, and then misses the rest. Well, there's 7 more chances, so he's missing it. So that gives us a probability of 0.000021, and it says to the nearest percentage in the question. So really important that. So rounding it to the nearest percentage then would be approximately 0%. So we don't use our Bernoulli trial here in the first case because obviously we're given a specific order. Okay, so part 2 then he hits the target exactly 3 times. So he's still hitting it 3 times, but we don't know when he's hitting it 3 times. So in this case what we're saying is, again, our number of trials is still 10. We have 3 successes, but we don't know where those successes are. P is still our probability of success, which is a quarter hitting the target, or Q then is our probability of failure, so not hitting the target. So therefore, for this one, we will have to use our Bernoulli trials because we don't know what order these 3 hits are coming in. So we have 10, choose 3, a quarter to the power of 3, 3/4 to the power of 7, and as a percentage then we get 0.25 as a decimal, which would be 25%. Okay, and that's coming from our formula n choose or, p to the power of or, q to the power of n minus or. Okay, so the difference between the first one and the second one is that we had no specific order here. Okay, so they can occur in any different order. So nearest percentage again is 25%. Part 3 then says he hits the target at least once. Okay, and we know with our formula for at least once, then it's going to be 1 minus none. Okay, so our number of trials is still going to be 10. If we're not hitting it, our number of successes is 0. P, our probability of success, is a quarter. Q, our probability of failure, is 3/4. So therefore the probability that he hits the target at least once is 1 minus none. So that would be 10, choose 0. And then P to the power of or, Q to the power of n minus or. And then that gives us 0.943686. So to our nearest percentage is 94% approximately. Okay. Oh. All right, so for The next question then is question 15 was asked. And again, if anyone else has any other questions, don't be afraid to ask. I have no problem in throwing up videos for homework at all, especially if you can't follow the answer in the solution that I would have given you in your folders, okay? So if we're looking at this one here, then we have Susan rings her mother, and the chance that her mother answers the phone is 3/4. So we would say the probability of success is her mother answering the phone. We're told that Susan rings her mother every day for a week. So that's every day in a week, which is obviously 7 days. So our number of trials, we would say, is going to be 7 days in the week. Number of successes will depend on the question. So P, our probability of success, we're going to say is that the mum answers the phone, and we're told that that is 3/5. So answers. And then Q is our probability of failure. In other words, the mum doesn't answer the phone, which would be 2/5. Okay. So in the first one, we're told that the mum answers exactly 4 times. So if she's answering exactly 4 times, again, these are independent events. We have a fixed number of trials. Probability of success and failure doesn't change, and therefore we can use our Bernoulli trials for this. So the number of successes is 4 times. So again, our formula for our Bernoulli trials is n choose or, p to the power of or, q to the power of n minus or. So that's our probability, okay? So we sub in the probability of exactly 4. And then it's going to be 7. Choose 4. P, we said, is 3/5 to the power of or. Q to the power of n minus or. So 7 minus 4 is 3. And then on our calculator, that gives us 0.290304. Now, we're not told anything about percentages or nearest decimal places, so I would give my exact answer that I'm getting on my calculator. I wouldn't round it unless I'm being told to round it, okay? The next one then is exactly 6 or more times, okay? So now we only have n trials is 7. So the probability for 6 or more means that the number of successes can only be 6 or 7. And we know when we're doing or that means we're going to add. So the probability that it's 6 or more will be our 7, choose 6, 3/5 to the power of 6, 2/5 to the power of 1, or means we add. So we'll have 7, choose 7, 3/5 to the power of 7, 2/5 to the power of 0. And again, on our calculators then, that gives us 0.15863304. Okay, and then if I go on to the next page, we're asked for on Monday and Tuesday only. Okay, now Monday and Tuesday are specific days. So again, this is like the previous question where we're given a specific order. In other words, the days in which she's going to answer. So therefore, our successes are going to be Monday and Tuesday, and means we're going to multiply and not the rest, okay? So therefore, what's the chances that she answers on a Monday? Well, if she answers on a Monday, that means she answers. So this is our Monday. Well, what comes after Monday? Tuesday, and she answers. So that's 3/5. And then we have the rest of the week. So we have she doesn't answer, she doesn't answer, she doesn't answer, she doesn't answer, and she doesn't answer. In other words, she's not answering on Wednesday, Thursday, Friday, Saturday, or Sunday. Okay? So in other words, the probability that she only answers on Monday and Tuesday only is basically 3/5 squared and 2/5 to the power of 5. And that gives us then 0.00366864. Okay? So again, we were given specific days here. Like if I go back to the previous question, where we were given the first 3 times. So again, there was a specific order given there. So we weren't setting up our Bernoulli trial in that case. We were just doing your normal traditional probability. Okay, so any other questions, just drop me a message and then I'll do out a solution for you, okay?